Okay. Hello, student. How are you? Good evening to all. I hope you are good and taking care of yourself and your study. So, here we are with the lecture number 8 in geometrical optics. Okay. So, yeah, good evening, Hitashri. How are you? I hope you are doing well. Okay. So, what we are up to with, we have covered 7 lectures, and till now we have dealt with the spherical, not the spherical, the plane surfaces, plane mirror, refracting surfaces, refraction, laws of refraction, and all the concept that has need to be taught in this JE level and NEET level. I have been taught. Okay. So today we are dealing with the lecture number 8 of geometrical optics. By the end of this lecture, you will find that prism, the chapter including the topic prism, has been completed by the end of this. Okay. So we will proceed further. Yeah. So firstly, the geometrical optics lecture number 8. Aim for today, what is this? Firstly, according to uh, the era that we are using in this lecture, we firstly going to recall the previous concept, then the condition for grazing emergence. Okay, I will deal it. Okay. Condition for no emergence and deviation and dispersion by thin prism, and also the combination of two thin prism, and that is all in the prism. So that is all you need to discuss, and I need to discuss with you. And after that lecture, there is no prism anymore. Okay, prism has been completed, will be completed by the end of today. Okay. So without wasting so much of time, let's get started with the lecture. So firstly, we will recall that we have learned so far in the previous lecture. So in the previous lecture, we are dealing with what is prism now. So I will tell you, I have told you that what is a prism. Prism is a solid homogeneous body, na? Okay, which is transparent also, in which the prism has number of faces, but on which the incident ray is falling, and from where the emergent ray is emerging, na, that plane should be non-parallel to each other. Okay, look, I will show you. Let me just select the pen color. Just a second. Yeah. So I have told you, like, this type of figure we are considering the prism, because this is the plane on which incident ray has been fall. This is the plane from where the emergent ray will emerge. So these two planes are at an angle theta, and this angle is the angle of prism. Okay, this is the refracting face. Refracting face, I have told you, and this is the emergent ray, emergent face. Okay, what is this ray called? This ray is the emergent ray. Okay, and this is the incident ray. Got it? So this is the prism that we have. ठीक है, मैंने आपको बताया था, I have told you कि not only this triangular shape of thing, this triangular shape type thing is not only the prism that you will consider. If you have a glass slab, ठीक है, and if you are passing the ray in this direction, incident ray is falling on this angle, and it is going through this face. So these faces are also inclined at some angle which is 90 degree. So this picture, this thing, this object would also consider as a prism. Okay, that is why if you have seen the soap bubble, okay, soap bubble, and whenever you washing your cloth, there are lots of bubble in the tub. Okay, and so there will you see, and there is a device come na, on which you blow blow the air, and there are lots of balloon types of bubble came out. So that will also, you will see on the surface of that, you will see all the colors, all the 7 colors with your pattern you will see. Okay, so that is also behaving as a prism by the, because of this property. Prism is the medium through which the ray is passing, no? Because it's only the refractive index of a material that causing the ray to be dispersed in 7 color. Okay, got it? So I hope you got this definition. Prism. Now deviation by prism we have deal. So we have derived a formula which is delta is equals to I plus E minus A, where I is the angle of incident, E is the angle of emergent. Okay, na? Emergence you can say, not the emergency. Okay, it's the angle of emergence. A, what is A? A is the angle of prism. I have mentioned all the thing. Na? Delta is the deviation. A is the angle of prism. I and E is the angle of incident and emergence. Got it? Then after we have deal with the relation between minimum deviation and refractive index of prism. So for your knowledge, delta minimum is this. For delta minimum, you can keep this point in your mind. I is equals to E and A is equals to 2R, where R1 equals to R2 equals to R. Okay, we have seen this na, in earlier lecture, why this R1 and R2 are equal. Okay, so from that, you will consider this formula mu p, which is the refractive index of prism, is equals to sine of del m. What is del m? Del m is the minimum deviation. Okay, del m not means the maximum one. It is the minimum deviation. Keep this in mind, na? Minimum deviation. Okay. Screen is visible to you, all of you. I'm audible to you. Okay. If any point of time you will find the screen is not visible or I am not audible to you, just write it in the chat box so that I will fix it. Okay. So this is the formula that finally we have in our hand. Okay. Okay. So I don't think you have any kind of doubt in this. Okay. And if you have, you can ask in the chat box. Now, we have seen a graph in yesterday's lecture. So what that graph is, this graph is drawn or plotted between delta, del, which is the deviation, and the angle of incidence. Okay, you have seen that at this particular point there is an angle I is equals to I dash, for which the minimum deviation you have. Before that, by increasing I, you will see a decrease in delta. Mean firstly, on increasing the angle I, angle of incidence, you will see a decrement in deviation of prism. Okay. After a point, it reaches a common value. For that, the minimum deviation you have by the prism. And after that, if you increase the I, it will increase the deviation of prism. So it is a kind of tricky, na? So firstly, it will decrease, then it has minimum value, and then it start increasing. Okay, got it? So learn this in this way: decrease, constant, increase. Okay, decrease, constant, increase. Yeah, decrease, minimum, increase. Okay. So on which factor, and one thing that I want to tell you also, I have told you yesterday also, that for these values, na, I is equals to I1 and this I is equals to I2, you have same value of deviation. Deviation is same for them. Okay, del 1. Okay, why is so? It is because of this nature, is because of, just a second, because of reversibility, reversibility of light. Okay, look, if this is a plane mirror you have, you put the light in this direction, this is the incident ray, after reflection it goes in this direction. But what if you send the ray in this direction by keeping the angle same, or what will happen, this ray is goes in the same direction of incident ray. So this is the principle of reversibility. Okay, you can reverse the direction of light, but it does not deviate from its path. Okay, so that is why if you have a prism and you draw an incident ray on it, after reflection it goes in this direction, but you just reverse the direction by keeping the angle same, by keeping the prism same, what will happen, what will happen, you will have the same amount of deviation. Okay, deviation is same in all the cases because the path of the light will not change. Got it? So this is because of the principle of reversibility of life. तो मैं इसे लिख भी देता हूं, I will write it for you. We have same value of deviation for different value of angle of incidence. Why? इस y का आंसर अब हम यहाँ देंगे, because of the principle of reversibility of light. Reversibility of light. Okay, that is why this is the only reason it is not, it is having the same deviation because it is not deviating from its path. Okay, the another part that we will discuss, that how the factor affect the radiation. Okay, sorry, affect the deviation. These are the factors affecting क्या, deviation. So refractive index of prism means mu. If mu increase, then deviation will increase. I have told you. Angle of prism. If angle of prism increases, then deviation increases also. I have told you in earlier slides that it will increase. Wavelength of light and the deviation part. Okay. So if wavelength of light increases, the deviation decreases. Okay. Got it? Means the light having the ray, yeah, the wave having maximum wavelength will deviate less. Okay, I will discuss it one by one. Okay, today this is our topic of discussion. So for first of all, we will deal with the condition for grazing emergence. What is grazing? Firstly, we will deal with this term, grazing. What is grazing? ग्रेजिंग को हिंदी में बोलते हैं चरना. ठीक है, चरना मतलब when you will see the cattle in field, so what they will do, they will eat the grass na. So we will not say that they are eating the grass, we will say that they are grazing the grass. ठीक है, the cow is grazing. Grazing means charna. Why this term is used here? ठीक है, why this grazing term is used here? Because you will see that this is the surface you have and this is the grass. ठीक है, this is grass on the surface. So when a cattle eat this grass, what is happening, this grass will only stick out from the surface. ठीक है, आपने कभी भी देखा होगा वो पूरे घास उगड़ के नहीं आती. ठीक है, इट इज नॉट कि आपको उसकी रूट भी दिखेगी बाहर, नो, द ग्रास विल ओनली बी ईटन बाय फ्रॉम द सरफेस. So this phenomena of eating the grass is happening only on the surface. ठीक है, that is why this is defined as grazing. So what do grazing doing in this concept? It is doing so because of this emergent ray. Firstly, what will happening? Emergent ray ऐसे आ रही थी, ठीक है. But if it is grazing, means it is moving along the boundary. ठीक है, on the interface of two medium it is moving. So it is grazing only on the surface now. That is why the term grazing is used here. Got it? I hope you got this now with this example of eating grass by kettles. Okay. So we are going to find out the condition for that. What will be the condition for that for grazing? So this is the incident ray that you have, and like this is the normal. I forgot to draw. This is angle I you will have. This is angle R1. Again, this is the normal. This is angle R2 you have. Okay. And from the normal, this would be the angle. So for grazing emergence, the condition is that condition for grazing emergence is you will write as the angle of emergence of light is 90 degree, means E is equals to 90 degree. ठीक है. What do we represent? Grazing emergence is represented by E. Sorry, emergence angle is represented by E, and angle of incidence is represented by I. ठीक है. So in this phenomena, this E is equals to 90 degree. Got it? ठीक है. For this E to be 90 degree, there is a condition, one more condition for this E to be 90 degree. And what is that? If anyone has any idea, just write it in the chat box. Huh? I will checking on it. Okay. And this concept that I am going to talk to you is from your previous lecture. Okay. So tell me, what will be the value of R2 if E is equals to 90 degree? Okay. Tell me. Write this thing in the chat box if anyone has any idea. Very good, Niranjan Reddy. Very good. यार इसका मतलब है कि you are paying attention to the lectures and it is good for you. It is good for you. ठीक है. So Niranjan Reddy has said that for this E to be 90 degree, this R2 should be equals to critical angle, like we have deal in the total internal reflection, critical angle. What is happening in TIR? This is the rare medium, this is denser medium. This ray is coming and it is moving along the boundary for critical angle. You have seen, na? Because if this is not the critical angle, this is any kind of angle which is less than critical one. So this ray move away from the normal. And for the critical angle, it moves along the boundary. This is the TIR. Okay? Very good, Niranjan. I hope the number in the chat box will increase soon. Okay? As Niranjan Reddy had got this, everyone of you have to got this, na? Okay? So R2 should be, the second condition will be that R2 should be critical angle represented by theta C. Okay. So apply Snell's law. Snell's law is always apply on the boundary. Okay. So we have two boundary here. First is this and second one is this. Here are two boundary on which the refraction is taking place. So you can apply the Snell's law on two sides. Okay. So on boundary 1, on boundary 1, what is the value of Snell's law? It is air outside, okay, and this refractive index is mu. So we can write it as refractive index of air, which is 1 multiplied with the sine of angle of incidence, equals to what? Mu times sine R1. Okay. So we can write that sine I is equals to mu sine R1. Okay, this is equation number 1 we have. On boundary 2, what do we have? Applying the Snell's law again. So this R2 is nothing but theta c. So we can say that this mu sine theta c is equals to 1 sine 90. Okay, because here the E is 90 degree. So we can say that mu sine theta c is equals to sine 90 is 1. This is equation 2 we have. Okay. We know that A is nothing but R1 plus R2. A is the angle of prism. Okay. So from here, we will say that if this A equals to R1 is nothing but R2 is theta c. So from here, you will say that R1 has a value of A minus theta c. Put this value in equation 1. Okay. So what do we have? It is sin I is equals to mu. If we put the value of R1, it is A minus theta c. So it will become, I'm writing it here. Pay attention to it. Sin A minus B is, you know the formula, na? Sin A cos B minus cos A sin B. Okay. So here we have A minus theta c. So applying the formula, sin A cos theta c minus cos A sin theta c. Got it? And from equation number 2, you will see that sin theta c is nothing but 1 upon mu. Okay. What will be the value of cos theta c? You can again use this relation, sin square theta c plus cos square theta c equals to 1. Okay. So cos theta c will nothing but what? It is 1 upon mu, na? It is mu under root of mu square minus 1 upon, okay, because in this you will see, just a second, put the value here. Sin square theta c is 1 upon mu square plus cos square theta c equals to 1. So cos square theta c is 1 minus 1 upon mu square, taking the mu square LCM. So it will be mu square minus 1 upon mu square, and square root of this will give you cos theta c as square root of mu square minus 1 divided by mu. Got it? So put this value here. You will have sin I is equals to mu cos theta c is square root of mu square minus 1 divided by mu, and mu got cancel out, divided by mu na. So this and this will get cancel out, so you can remove it from here. Okay, into sine a minus, what is sine theta c? It is nothing but 1 upon mu cos a. ठीक है, got it? So this is the final formula that you have in your hand. Sin a is square root of mu square minus 1 sin a minus 1 upon mu cos a. You can do some of the modification in that. What you can do, you can take the sin a as common, so you will have square root of mu square minus 1 upon mu tan cot a. Okay, so that would be the simplification. Only one trigonometric ratio you have in the equation. Okay, so you can do that. For here I'm writing it here for the modification part. It is sin I is equals to uh, if you take sin a common, so it is mu square minus 1 square root of mu square minus 1 minus 1 upon mu cot a. ठीक है, this is the formula, final formula that you have in your hand. Okay, so if anyone have any kind of doubt, just write it in the chat box. Otherwise we will move forward. Okay, what do we have to do here? There is two condition. First, the angle of emergent ray is to be 90° for grazing emergence, and second condition that R2 angle, this R2 would be equals to theta c, critical angle. You can do this. This is the mathematics that we have done. Okay, so learn these two conditions, focus on that. Now condition for no emergence, what should be the condition for no emergence? Look, if this angle R2, this is the angle R2 na, if this angle R2 is greater than theta c, okay, or I will say that this is the incident ray, this is the path of incident ray. Okay, here TIR is happening, so this ray is not going to graze the boundary, okay, or outside the boundary, it is getting reflected. Okay, so what do we have? We have A is equals to R2 plus R1. For R2 you can say it is nothing but A minus R1. Okay, or for R1 also you can say, for R1 also you can say A minus R2. Okay, same thing. So we will do it for the R1. R1 is equals to what? A minus R2. So what could be the maximum value that R2 can have? Okay, R2 can have the theta c. Okay, if theta c is the maximum value, if this theta c is the maximum value of R2, so this R1 having the minimum value, because this is a constant quantity, and if you are subtracting maximum from this constant quantity, so on the LHS you will have the minimum value. Okay, got it? Similar to that, it is 10 minus x. Okay, and it is y. So if x goes to increase maximum value, you will have y as minimum. If x has a range of 0 to 9, okay, so maximum value of x is 9. So if I just put 9 here, you will have 10 minus 9 equals to 1, which is minimum for y. Okay, and maximum के लिए you have to put x as minimum. You will put 0, then y will have 10, and this is the y max. Got it? I hope you got this. Okay, so we have maximum value of angle is theta c, and R1 is equals to A minus R2, means R1 minimum is equals to, or we can say that, just a technical error I have made here, sorry for that. Yeah, just a second. Focus on this. This is the normal. This is R1. ठीक है. This ray making an angle of incidence I. So what do you have if this ray get refracted from here? ठीक है. So what should be the maximum value of R1? R1 के लिए maximum value क्या होगी? Because R1 के लिए maximum value हो सकती है कि if this R1 is theta c, the critical angle, because R2 can extend its value, na? R2 is greater than theta c in this case. You will see. Okay, got it? So this value is R1 that can have the minimum value. Okay, just give me 10 seconds. Yeah, guys, I'm here. Sorry for the trouble. There are some network issue that I have to fix na. Okay, so no problem. So what I'm talking about, this R1, okay, is somehow dependent on this R2, because this is the formula that we have. A is equals to R1 plus R2. This A is constant. If you increase the R1, if you increase the value of R1, so that would be a reduction in R2. It is must. Okay, got it? Up to what point you can increase the R1? You can have the R1 as theta c, because if R1 exceed the theta c, the total internal reflection will takes place. Okay, total internal reflection will take place on this boundary, on this first boundary also. Okay, if you just reverse the direction, if you just imagine in this direction, this is the TIR for the condition of TIR. Na? If R1 has a value of theta c, this ray not going instead of in this direction, it will grazes the boundary. So this is the maximum value it can have, because if we increase the theta c, this ray is not going outward. This ray will just travel inside it. Okay, got it? So this R1 can have only the maximum value as theta c. I hope you got this concept. This is R1, this is R2. Okay, so we are interested in R2 because on this boundary, this TIR is taking place, or this no emergence is taking place. So we are interested in finding the value of R2. So it is A minus R1. And as I have discussed, R1 can have only maximum value as R1 max is what? Theta c. I have told you na in this side. So this R1 max can be theta c. Okay. So if this is maximum, so this R2 will be minimum. Got it? A minus theta c. Now tell me, this R2 has the minimum value as A minus theta c. What if this minimum value is greater than theta c? So if the minimum one is greater than theta c, then if you move above, if you move on the much higher values, so it will also greater than theta c, means there is no TIR can happen. So there is no grazing can happen also. So means the condition for emergence, no emergence will be followed by when R2 की minimum value ही greater than theta c. Okay, that should be the condition for no emergence. So condition is that, I hope you got this. Let me tell you once again. We have theta c. If R2 become theta c, we have grazing emergence. If R2 increase the value of, if R2 has an increment in its value and it increases the value by theta c plus something, means R2 has a value greater than theta c. What can happen? The TIR can happen. Okay. I have calculated the minimum value of R2, which is A minus theta c. Okay. If this minimum value exceeds the theta c, which is the critical angle for the boundary 2, what will happen? There is no emergence. Okay. There can be no emergence. Okay. We have the minimum value. Other values are greater than the minimum one. Okay. So we have the no condition. We have condition for no emergence. So keep this in mind. Condition is that this R2 minimum is greater than theta c. Got it? So what is the value of R2 minimum that we have calculated? It is A minus theta c greater than theta c. You will have 2 times of theta c less than A. I have just reversed it. Okay. It is A is greater than 2 theta c, which means 2 theta c is less than A. So here you can see that theta c is less than A by 2. So this is the condition that we have. And for more formula, you can see that sine theta c is equals to 1 upon mu, refractive index of material. So put the value 1 upon mu here. So you have 1 upon mu is less than A by 2. Okay. So you will, if you reverse the, so this inequality will reverse itself. Okay. So you have mu is greater than 2 by A. Okay. So these are the condition for no emergence that you have. Okay. Got it? So this is it. Condition for no emergence. If you have any kind of doubt, you can ask. Okay. So I think you are so smart, kids, because from the day one, from the lecture one, you are barely having any kind of doubt. So I hope you are too genius for ray optics. Okay, for physics also. Okay, so yeah, deviation by thin prism. In the earlier lecture, what the deviation that we have seen is from the general prism. Here, the prism is thin. Okay, patla prism hai, chota wala. So what is the condition for that? Means I, E, R1, R2 and A are very, very small. Okay. So this is the deviation by thin prism. This is the deviation. This is incident ray. This is the incident ray. And it is the emergent ray. Okay. From it is the normal. And from normal, this angle is E. And this angle is the deviation because it deviates from its actual path. Okay. So yeah, it is del 2. Del 1 is here. The total deviation is this. This. Okay. This is delta. I will remove this. Okay. So this is the total deviation that you have in this case. Okay. So for thin prism, you have to keep this in mind that this I, E, R1 and R2 and A angle of prism is very, very small. Okay. बहुत छोटे होंगे angle. This is A. Okay. So for the deviation, what you will do? Deviation you have del is equals to I plus E minus A. It is from the general one you will have. Okay. So if you are encountering the deviation from a thin prism, so what do you have in that condition? you will have that this I, this is the angle of incidence, and this angle of emergence, and this angle of prism are very small. Okay. So this is the only condition that you will have to keep in your mind. So yeah, and here A, you can write it as A is equals to A is equals to R1 plus R2. Okay. So just a second. Yeah. So we are up to with this. You will now you understand these angles are R1 and R2. No? Okay. So we are applying Snell's law. This is equation 1 we have. We are applying Snell's law. Applying Snell's law. On boundary 1, if we apply it, it is nothing but 1 sin I equals to mu sin R1. Okay. And on boundary 2, it is sin R2 mu sin R2 equals to what? 1 sin E. Because these are angle very small, so we can consider sin I as I, sin E as E, and also this is happen for sin R1 comma sin R2. You can consider it as R1 and R2. Okay, that directly I have written here. Got it? So what do we have? We have sin I means I is equals to mu R1. It is mu R1. Okay. And mu R2 we have equals to E. Okay. Got it? Put this value in this equation. Equation number 1. Delta is equals to I plus E minus, we extend the value of this R1 plus R2. So what do we have? What is I? Or you can just keep it as A. I will do it for you. Okay. So for the better understanding of yours. So I is nothing but mu R1 plus E is nothing but mu R2 minus R1 plus R2. If you take mu common, it is R1 plus R2 minus R1 plus R2. R1 plus R2 is nothing but A. It is also A. So it is mu into A minus 1. Okay. Sorry. You can take A as common. So it will be mu minus 1 into A. So this is the deviation produced by thin prism. It is the deviation by thin prism. Okay. Got it? So for different colors, like we have violet color. So what is the deviation of violet color? It will be refractive index for violet color minus 1 into A. This is the way to writing it. So if you want to write it for yellow color, so it will be mu V minus 1 into A. If you want to write it for red color, so it is mu R minus 1 into A. Got it? So this thing you have to keep this in mind. Got it? So I hope you are clear with this. Okay. Now we will move on to the next part of it. Yeah. Dispersion. This is very important thing. No? Dispersion. You have seen the rainbow. You have seen the soap bubble. No? You have seen the prism also. So what it is doing, the white light is falling on it and it is dispersing it in the uh, different colors. And these are not the infinite number of colors are there. There are only 7 colors which can be denoted by the abbreviation VIBGYOR. VIBGYOR. Every letter in this abbreviation represents a name of the color. So what is the dispersion? So we know that white light is made up of different lights, like 7 color combination we have. Okay. Just do one thing, take a paper, cardboard, and You will draw, firstly you will paint it white, then you will paint all the colors in it, 7 color. Okay, and try to rotate it as much fast as you can. You will see that the after rotation, if you are rotating it, the color of that cardboard disc would be white. Okay, so this white light is made up of 7 different colors. Okay, yeah. What is happening, this mu of the refractive index of any prism or any material, I have told you, this mu is the optical friction. In air there is no optical friction, so the white light is moving, all the colors in white light moving in the same direction and in same speed. But when it encounters the mu, any mu, okay, any surface, what happening is this mu has a dependency. Mu is equals to c by v, so it is inversely proportional to the velocity of any color. Okay, means which colors is moving fastest, उसके लिए mu is the greatest. Okay, sorry, we, if v increases, so mu will decrease. Got it? Now there is a very beautiful relation. You can see here the white light is, and it is dispersing in this 7 color pattern. Okay, so this process, the splitting of white light into 7 colors, is termed as the dispersion. For the definition purpose, you can learn this. Okay, now if we move next to it, yeah, the dispersion by thin prism we are only dealing with. So this is the white light. Okay, it is the white light, yeah, white ray of light. Okay, it is dispersing at some angle I, and it is got disperse. So I have mentioned 3 lines here, so I'm dealing only with the this is violet, del v, this is del yellow, and this is del r. Why I'm doing so, why I'm writing del v is this line only, you will get to know about this. We have a very beautiful formula, or you can say a relation, which is known as Cauchy formula or Cauchy relation. What is that? Cauchy relation tells us that refractive index of any material will depends on the wavelength by this relation, and so on. Okay. From that, this formula is has no use like in terms of numerical input. ठीक है, इसके लिए नहीं घबराना. We are only interested in the conclusion of it. And what is the conclusion? That mu is inversely proportional to lambda. Okay, means as wavelength increases, mu decreases, or you can say if mu decrease, then wavelength increase. Okay, and for the dispersion by thin prism, you will get to know that this del v, this delta, is nothing but mu minus 1 times of a. Means if mu increase, then delta will also increase. Okay, from a pattern of Vibgyor, Vibgyor. ठीक है, 7 color, violet, indigo, blue, green, yellow, orange, red. ठीक है, so from violet to red, wavelength, what happens to the wavelength increases. Keep this in mind. ठीक है, if you move from violet to red in the spectrum also, you will see, so violet is placed firstly, then in the last we have placed r. Why it is so? Because this violet color has larger part of energy of light and its frequency is greater. Meanwhile, it is have a lesser wavelength. ठीक है, if the frequency increases, wavelength decreases. ठीक है, so this relation is hold good for frequency decrement. ठीक है, सो जैसे जैसे आप वॉयलेट से रेड की तरफ बढ़ते हैं, द वेवलेंथ इंक्रीजेस. गॉट इट? इफ वेवलेंथ इंक्रीजेस, if wavelength increases, what happens with mu? Mu got decreases. Mu decreases from Cauchy relation we have. ठीक है? So if wavelength increases, mu decreases. ठीक है? If mu is decreasing, what is happening with del? Deviation. Deviation is directly dependent on. Deviation is directly dependent on mu. So mu is also decreasing. Means delta is also decreasing. Means the color have greater wavelength. जिसकी जितनी ज्यादा वेवलेंथ उसका उतना कम डेविएशन. गॉट इट? जिसकी जितनी ज्यादा वेवलेंथ, द कलर हैव longer wavelength have lesser deviation, and the color have shortest wavelength having the maximum deviation. So you will see here this del v, why I have placed in this line also. This del v has the maximum wavelength, sorry, the minimum wavelength. This violet color has minimum wavelength, and wavelength is, you can see here, if wavelength increases, the delta decreases. Means it has maximum value of, if delta is minimum, then this, sorry, if lambda is minimum, which is the wavelength, so this delta would be maximum. Got it? This maximum deviation we have. So if you measure the deviation from this is the greater angle. This angle is less than it, and this angle is less than. So the minimum angle of deviation have, which color have the minimum deviation? Which has the larger, which has the longest wavelength. So red color have longest wavelength. That is why it is showing you the minimum deviation. Okay? And the blue color has the, or the violet color has the maximum deviation. That is why if you on a torch which having a blue light, you will see it is more dispersing in nature. It will more disperse. And if you have a laser light which is red in color, so what will you see? This light goes a very far distance away, because it does not deviate from its path, because it has the uh, larger value of wavelength. ठीक है? सिंपल से रिमेंबर रखना है. What do you have to do? You have to focus on two factors. It is becoming four. You have to focus on only two factors. One is wavelength and one is deviation. If wavelength increases, deviation decreases. ठीक है? So larger wavelength, minimum deviation. Greater wavelength, lesser deviation. ठीक है? So इसीलिए on every sign of warning sign or the backlight of any kind of vehicle that is moving, or any kind of surveillance, any kind of emergency light, are red in color. You will see when airplane flies, it has a color red. On the top of the tower, what color light you have? Red. Okay? On the back side of any vehicle, what kind of color you have? Red. Why it is so? ताकि दूर से दिख जाए, because it is not deviating. So if you are a distance, far distance away, it comes to you without so much of deviation. Got it? This is the beautiful nature of light. Okay? Got it? So if I summarize this, for you, what do you have? You will have, I have told everything that is needed. Okay? So if wavelength increases, if wavelength increases, the deviation deviation decreases. ठीक है. So deviation for violet color, what do we have? It is having a value of deviation of violet color is mu of violet minus 1 into a. What is the value of deviation of red? It is mu of red minus 1 into a. And what is the value of deviation of yellow? It is mu of yellow minus 1 into a. ठीक है. Got it? The next part is the dispersive power. So dispersive power is nothing but, I'm writing the definition of it. It is the ratio of, it is the ratio of angular dispersion, angular dispersion to the mean deviation. Mean deviation. Okay, got it? So it is nothing but the, it is not ration, it is ratio. So it is the ratio of angular dispersion to the mean deviation, and it is given by, it is given by omega. This is not W, it is omega. Okay, so omega is the ratio of what is angular dispersion? It is theta divided by what is mean deviation? It is delta mean. I'm not writing it del m because you got confused with the minimum deviation. No? So what is the value of theta? Angular dispersion. Angular dispersion. Dispersion. ठीक है. So angular dispersion is nothing but it is the difference of maximum deviation, which is del v minus del r. It is the difference of maximum deviation to the minimum deviation. Difference of maximum deviation to the minimum deviation. And from the formula we know that the maximum deviation is caused by violet color deviation. Okay, so maximum deviation is caused by violet color because it has the lesser wavelength, and minimum deviation is caused by red color because it has the longer wavelength, largest wavelength. Okay, yeah, longest wavelength you can say. So what, how do we calculate this delta? So you can write it as omega is equals to, what is the value of theta? It is del v minus del r divided by del mean. So how do you calculate this del mean? Del mean is the, just a second, del mean is the sum of greatest deviation, sum of with the minimum deviation divided by 2. So in a general, this del mean, practically what is has been found, this del v plus del r divided by 2 is approximated to the deviation by yellow color. Okay, so it is the mean value of color. So omega here we can write as del v minus del r divided by what is del mean? It is del y. Del y. Okay. So you can see here this dispersive power only depends on the angle of deviation. ठीक है, you will write it as like another formula. You will have omega is equals to, what is the value of del v in terms of refractive index? It is mu v minus 1 into a minus mu r minus 1 into a divided by mu yellow minus 1 into a. This a will cancel out because you take common a, and from the bottom side it will get cancelled out. So omega is nothing but what? Mu v minus mu r. This 1 and 1 also got cancelled out, divided by mu y minus 1. So from this formula you can see that, you can see here this point to be noted down. What? This omega depends on, depends only on the medium. ठीक है, so this dispersive power is controlled only by the medium because here is no angle of prism is taking place. But if you will see this theta, which is del v minus del r, and if you put the value of like this mu v minus 1 into a and mu r minus 1 into a, so you will have what? Mu v minus mu r into a. So it depends on, it depends on both कौन? Angle of prism and the material. Okay, so these 2 points you have to note down. Okay, so this is it from my side, guys. Thank you so much for attending the lecture. If you have any kind of doubt, you can ask. Otherwise, the lecture has been over now. Thank you so much for attending the lecture. Okay, and take care of yourself and study well. Okay, focus on your study, be disciplined, be hardworking, and be consistent. These are the keys to success. Okay, consistency and discipline and hard work. Okay, if you forgot to do the hard work, just maintain your consistency. Okay, this is the only key that would you know, keep the discipline and hard work in line. Okay, got it? So thank you so much for attending the lecture. Thank you so much. Take care and be safe. Keep studying. Thank you so much.